Welcome everyone. We are going to start the event. Let me introduce myself. My name is Paolo Vinciacchi. I am the CEO of e-GEOS. So I will start. I would like to start to give you, let's say, some introductory speech. So welcome everyone to the CLEOS Go Live, the e-GEOS digital platform. The event focuses on the new e-GEOS marketplace, CLEOS. First of all, I would like to thank the speakers who will take the floor during the roundtable, the technicians who will illustrate CLEOS structure and benefits, and the audience. We already did an overview on CLEOS in the past days, answering to the question, what is CLEOS? Today, indeed, during this event, we will explore the numerous applications of our platform in the industrial, civil, and defense fields. CLEOS opens new economic scenarios in the field of geographic information, improving the accessibility and interoperability of data and services, thereby contributing to unlocking information. The ease of access, the possibility to integrate the e-GEOS services with larger ICT ecosystems make our platform a perfect spacecraft of the new space economy, because it allows filling the gap of pervasiveness that afflicts spatial information. In fact, CLEOS has a service-oriented architecture, a structure that allows platform to interact and cooperate with other ICT systems to exchange real-time data, providing full management of the system, flexibility in operation, and investment guarantee. In other terms, CLEOS aims to create a bridge between the geoinformation field and non-space business to meet market demand for space data and services that has exponentially grown in the recent years. It is the sign that companies are starting to recognize the great potential of the spatial supply chain, and we cannot miss the opportunity to lead them into a brighter future. We imagine a future where businesses, institutions, and associations can draw on open, smart platforms to meet their needs, and we want to give our support to build this future. We believe that in the world to come, the platform economy will play a key role in fostering cross-domain while ensuring the confidentiality, integrity, and availability. This belief is the origin of CLEOS, a platform that tends to form a virtuous mechanism that ensures advantages both for the user and for the marketplace itself. The user can leverage e-GEOS and no-e-GEOS data and services provided by e-GEOS and our partners through a smart, immediate, and highly responsive platform. On the other hand, the already rich e-GEOS portfolio can be smoothly injected in our partner offer, therefore enriching CLEOS range of services. In conclusion, CLEOS is much more than a platform. It is a great opportunity for the Earth observation field to penetrate new markets and to push the economic growth in this cumbersome time. Have a nice event. Okay, thanks, Paolo, for the introduction. Now I leave the floor to Manuel Peugeot, Secretary General of ERSC, so the European Association of Remote Sensing Companies, that will lead the first roundtable of this event. So, Emmanuel, the floor is yours. You are now the presenter.
Thank you. Thank you for this opportunity to moderate this session. CLEOS is the result of the vision of e-GEOS. It creates a momentum because of the new capabilities offered to users, customers, because of this significant investment, an investment made by the private sector to open the access to AI to other entities, to develop new solutions, new layers of informations which will fit with the user needs, which may help to tackle challenges. My name is Emmanuel Pajot. I am the Secretary General of the European Association of Remote Sensing Companies, ERSC, trade association representing the Earth observation downstream industry, representing 128 companies from 25 countries in Europe. In this roundtable, I have the pleasure to welcome Gunther Landgraf from ESA, Head of Earth Observation Program, Digital Platform Section, Mr. Francesco Barbato, European Commission's DigiDefis in the Unit B2, Space Research, Innovations and Startup, Greg Scott from the United Nations and from the Global Geospatial Information Management Sections, Department of Economic and Social Affairs, and Mr. Piers Francesco Cardillo, e-GEOS, Head of Digital Transformation. Over the last few years, the way to access and consume data has significantly changed. We saw the creation of impressive numbers of platforms to provide processing capabilities in the cloud, to access the data, Copernicus, Sentinel, or other commercial data, to exploit this data, and to inform and or sell Earth observation data and added value services. Platforms are no key component of the Earth observation ecosystems. Platforms are opportunities to, for example, leverage local IT limitation, to support the visibility of companies, to connect with potential users, customers that may not be reached otherwise. As an example, ERSC, with the support of ESA, launched EOMO, the web platform dedicated to promoting online Earth observation-based services. And we can see a growing interest from both companies and communities of users. But platforms are also very difficult to design. A survey we did illustrates the challenge platform developers and owners have to manage. They have to be easy to find. And less than 60% of users consider it is the case. The offer has to be really transparent, and only 40% of users agreed. Interfaces have to be user-friendly, and only less than 20% agreed on this. Platforms are as well a competitive area, where stand, for example, platforms developed in the course of European projects, organized by national platforms, commercial ones, and other big international players. The current landscape to access the Copernicus Sentinel data is representative of this diversity. But we have very positive signs. The progress of the use of Copernicus services in the last report we published, for example, the number of DIAS commercial users as well. So to fully exploit the potential of platforms, we really need to understand the need of the users and potential users. On one need are clearly been expressed by a community ERSC is working with, Parsec, a project ERSC is leading, and it is artificial intelligence. 90% of companies were interested to have access to AI expertise and tools. So, Mr. Landgraf, you are deeply involved in the development of the platform ecosystem at ESA and the development of federations. What are your views and the current needs to develop the use of this platform and the potential market opportunities?
Thank you, Emmanuel. So I think this platform action is really central. We know, especially in Europe, that the value adders who create the information are mostly small and medium enterprises or micro enterprises, even 1 to 2 people. And in particular, I think where we need to expand on Copernicus, especially the national use, and the people who serve the cities or the regional actors are yeah. So all of these people to work efficiently. I mean, what does a platform do? It allows you to come quicker to the market and to offer your operational services cheaper. So I'm convinced the EO business uptake will be platform driven, and I'm convinced that the platforms are decisive and able to do that. And I'm very happy to see this CLEOS, a very, very important European offering here.
Mr. Barbato, AI needs data to learn, and data needs AI to be interpreted and deliver value and insight. What is for you the role of platforms like CLEOS to shape the future of data infrastructures and connect to larger data ecosystems?
Hello, good morning, everyone. First of all, let me thank all the organizers in e-GEOS for the invitation. And I'm very pleased to be here to discuss the very important issues with you today. So before I go into your questions, just I want to make a small remark, and you will see how it is connected. I work at the European Commission, and I'd like to share, one policy element, one policy vision about all this. And this is all about, in a way, the new structure in which we work as a space DG. So you may be aware that DG Defis has been created this year to manage the space program and defense industry. This DG is part of the family of the DGs under Commissioner Thierry Breton for Internal Market, together with DG Connect. And DG Connect is the DG managing the digital portfolio in the Commission. So we're working together with our colleagues on digital, and I think this is already says something, about the intention of the Commission to make synergies between digital and space more evident and more stringent. This is also because there is quite a deep realization in the Commission, and this is not recent, and this has been exemplified by several communications of the Commission in the past years, and this is how data is pivotal as a policy element. And of course, space data is very much part of all this. Here, before I welcome CLEOS as a European infrastructure into the panorama of European infrastructure and service, the data economy and the space data economy, as it was mentioned before, I would like to mention a couple of words about the latest communication on data that the Commission issued in February 2020, which is the European data strategy. And in this strategy, the European Union set the scene on how it wants to support the European data economy with policy and innovation measures. And of course, in doing so, it does not forget space data, quite the opposite. It mentions space data, and in particular, Copernicus data, in which the Commission and the Union have invested so much resources to make it an operational program, a very successful one. It wants to support space data to be integrated into the European data economy. And for example, together with the Green Deal objectives, into a Green Deal data spaces through new initiatives such as Destination Earth, that is very consistent with the topic of the PHIWEEK this week, that is creating this digital twin of planet Earth to perform simulations on our planet. So this is all consistent with creating infrastructures that support the European data economy. As I said, space data is definitely a first-class citizen of this discussion. It has not been left out by the highest level strategies of the Union. And I think that any industrial initiative such as CLEOS is very welcome from the strategic point of view, from the European point of view. We know how competitive the market of data is, in particular when we talk about cloud infrastructures. I don't need to mention what the competition looks like and who the players are, but any new initiatives that gives Europe a competitive advantage in this domain, or it contributes to give Europe a competitive advantage in this domain, is definitely welcome. And it also helps doing something else, such an initiative. That is, try, as it was correctly said by Paolo Binciacchi at the beginning, connect space data to other data assets that are non-space. And in order to do so, we still have quite some work to do, I think. But these kind of cloud platforms that put the basis for connecting more systematically to the web of data, Earth observation imagery in general, I think it's definitely very useful to maximize any return of investment that we have done as companies or as institutions into Earth observation and geospatial systems, because this will open up new opportunities for exploitation of our data, and it will ultimately contribute to the goal that I was saying before, that is make Europe more competitive in this field.
Thank you. Mr. Greg Scott, the sustainability development is the challenge of our generation. This is what we want to tackle with this destination Earth on the European Green Deal, for example. All platforms like CLEOS could help in supporting the process of democratization of access to information, including geospatial information.
Thank you. And thanks for the opportunity to be with you all today. And congratulations on the e-GEOS digital platform and CLEOS. Thanks for those questions. And I think one of the things that we in the UN have in our global geospatial community is this mantra around the concept that everything happens somewhere. And ironically, in this time of global pandemic, that's become more relevant than ever, and a greater recognition is now being applied to this. For us within the UN and across our countries, we see geospatial information and data itself as part of this digital currency and a key component of evidence-based decision making. It's also part of the national infrastructure, and it helps shape and create a knowledge economy. It provides a blueprint for countries moving forward and to understand more about what's happening where and why and how. And so for us, excuse me, geospatial information becomes a more integrative approach to information and information services. It contributes to economic growth, to national security, to sustainable social development, environmental sustainability, and national prosperity. And this is actually why in the 2030 Agenda for Sustainable Development and its 17 Sustainable Development Goals, this agenda explicitly recognizes the need to strengthen the capacity of national data systems and also to exploit the contribution to be made by a wide range of data, including Earth observations and geospatial information. And we all know in this call that that is hardwired into the 2030 Agenda. But addressing these data needs is really critical to also measuring and monitoring the implementation of the SDGs and global development. And at the global level, we talk more and more now about this data ecosystem, interoperable, standards-based data, an integrated and federated system of systems approach, leveraging new data sources, digital transformation, and new and emerging technologies, and particularly innovation. It's really important that we continue to innovate. And this is where CLEOS comes in, and this is where it has a key role. CLEOS makes the sharing of knowledge, capabilities, and products easier, and easier to build and exploit Earth observation services and business applications in new ways. So this is part of this innovative digital transformation, and as has just been said, connecting data. So the process of democratization and access to data and information, including geospatial information and Earth observations, along with removing the old ways of silo approaches within and across countries, and that we become more user-centric, and we're putting data in the hands of citizens, is absolutely key to the success of the SDGs and even global development. So CLEOS is a key element of this going forward. In terms of what we're trying to do in the UN in respect of these sorts of processes, data has now become the new oil even in the UN. The Secretary General has just released a new data strategy for action by everyone, everywhere in May this year for the next 2 years. And it sets the strategic foundations for a data-driven transformationally. Additionally, the UN is also developing a geospatial strategy itself. But these are primarily aimed at the UN system, not so much our countries or our member states. And this is where within UN GGIM, we have now developed what is known as the e-GIF, the Integrated Geospatial Information Framework, and with direct application to the SDGs. Simply, the e-GIF provides a basis for guiding countries to strengthen, to integrate, to maximize geospatial information, Earth observation, and in fact, the management of all data within and across countries, and bringing a location element to it. And this is really going to be key. It's a framework. It's going to be a means for countries to implement capability in such a way that any system and any platform is able to be leveraged and integrated. And this is the key word of this framework: integrated, federated, system of systems are about our new data ecosystem in the future. And along with CLEOS, that's going to be critically important in the days and years ahead. Thank you.
Thank you. Mr. Pier Francesco Cadillo, what is your view, the industrial point of view, and the potential impact of this platform on this platform economy and the data proliferation?
Thank you, Emmanuel. So first of all, I would like to thank you all our guests right now, because the United Nations, the ESA, and the UNGGIM are explaining what is happening in the fact in our market. Our market is changing a lot. We are now experiencing the platform economy, and all the industries are trying to answer to this challenge that has been launched. So to work all together to create the system of systems, as Greg said, to share the data and to try to unlock the value of the data that are still trapped there. Because the fact is that we have a quantity of data that is growing a lot. We have a quantity of sensors that are flying in the sky or over the earth. The drones are coming. So the fact of the data is new oil, yes, but we have to be able to exploit this quantity of data, to merge different kind of data, to share our knowledge. So that's the philosophy of CLEOS. The first thing is to make data available. As you may know, Cosmos SkyMed is our key key satellites data, and has to be shared to the most of the markets that are now eager to treat this data. And thanks to CLEOS, we have a new door to access, to a new gate to access to this data from the Italian constellation. The other fact is that the experience on the radar that a company like e-GEOS, coming from the Telespazio experience, is beneficial for also the new startups that are coming into the market, and they are asking a new way to interact with our knowledge. So thanks to an API access, we will be able to share this knowledge with also the oncoming companies and experts for single market that would like to work with this data. So another point is new technologies that are coming. We are talking about artificial intelligence. We are talking about evolution of workflows. We are talking about also integration between platforms. This is another point that help us to go in the deep to touch the needs of the single customers, because they now have some need specific requests and not only scientific requests, because the effect of the international and particularly European activity is that the Earth observation is now part of our actual life. And a good sign that I would like to highlight, that we have a domain extension. We have Dirt or Earth. That is something that is new, but it seems that the Earth observation and the Earth interesting in general is something that is becoming common even in the domain in internet. So this is a point, a sign that we have to follow. So, okay, I say something in general, but I would like to leave the floor and to show up CLEOS in the fact. So I leave the floor to Domenico. Before, I would like to thank you to moderate this session. And thanks to all our guests to stay with us during this launch event in the PHIWEEK, and for the words that you spent for us, because it's important to us to understand that we are in line with the institution ideas of sharing economy, platform economy, and data policy that is in line with our goals. So thank you so much. Okay, so the second part of this event is quite more technical, and we are going to deep dive into CLEOS. And before, I would like to thank you all the teams that developed CLEOS, so particularly the e-GEOS team coming from digital transformation, artificial intelligence side, and platform development. So all the teams that works a lot to create what we are going to show. And all our partners that are behind CLEOS. That is, first of all, Accenture, that is our integrator, and also the vendors that are Salesforce, Zuora, and all the open source platforms that are cooperating with us. This is, I mention also them because they are involved into the development, because we are touching a new level of development in CLEOS. So Domenico, I leave you the floor, and thank you for showing CLEOS.
Excellent. Thanks a lot, Pier Francesco, and thanks to all distinguished guests. So I will lead you through this technical session, and let me just first have a few slides to introduce you to the concept of CLEOS. Then we will go through a live demonstration of the platform, and we will close this session with more technical insights and details provided by our technical team at e-GEOS. Good. So what's CLEOS? Well, CLEOS is our digital infrastructure to access the whole bouquet of services and products of e-GEOS. It's a new digital marketplace. So we focused a lot on the concept that CLEOS has to be able to easily let customers from different communities to access to clearly satellite data, both open source, free and open, as well as commercial assets that e-GEOS directly operates, like Cosmos SkyMed and soon Cosmos 2nd generation, where we retain full worldwide commercial rights, but also data provided by third parties, being them satellite and space data, but also data coming from other sources. And we are putting together a lot of partnerships to make CLEOS as a rich data environment. But it's not only about data. It's also about microservices. In CLEOS and through CLEOS, customers can access to a wide set of different processing services, and soon they will be also able to bring their own in the platform and chain them with other components. So CLEOS is meant to be an agile development environment. Well, we are live. This is great news. So after 1 year of development, we would have not believed that we could be able to be online since September 23rd. So you can go to www.cleos.earth, you can register, and you can start playing with the platform. We had a commercial launch event last week, more than 16 global guests. We had also an internal presentation in Leonardo, because this is quite a relevant initiative also in our big parent company. And this is actually the very first operational digital marketplace in this sector. Well, CLEOS brings together different functions and different platforms to be able to provide a unique user experience to our customers. We are actually heavily leveraging on Salesforce, as Pier Francesco was mentioning. We are in the cloud. We are deployed on AWS, and we are ready to deploy on any other kind of infrastructure, including the DIASys, where we have already links to and ready to deploy on Mundi and on Onda, and soon also on e-GEOS. And we use our own developed software by our startup in Luxembourg, that is AirTrab Luxembourg, and that is MaxSES platform for handling multi-cloud, hybrid cloud, and scalable microservices. Mariano and Simone will give many more details later on in the session. Well, from a high-level perspective, CLEOS provides access to contents and data, and being able to deploy on different infrastructures. And it's composed by these 4 building blocks. Well, data lake, where we manage data from different sources and missions. A processing platform that is scalable and elastic, where we are able to deploy, take under control, and measure different kind of processors. And maybe the new thing is marketplace. It works. You can buy on CLEOS. You can buy data. You can buy processing services. We are now starting with, let's say, prepaid contracts. Soon it will come also credit card payment, because we have changed the way through which we sell data and services. And we have been transforming also our help desk and customer service to be able to sell even few dollars, few euros of services, and being able to bill, invoice, and also receive the payment, as a lot of companies are doing today, for instance, in the telco market. Well, it's important to stress how CLEOS is expanding e-GEOS offering. Before CLEOS, we were able, let's say, to offer our tailored vertical solutions. So we have been talking a lot about our vertical platforms. And of course, we were able to provide access to multi-mission commercial satellite data. With CLEOS, we have 3 brand new things. The marketplace, I was commenting before, a new catalog of capabilities. So it's not about the data platform, but also the possibility to launch processors to generate intermediate and value-added products, and the developer portal. We are actually changing the way the company is developing software and is developing geospatial applications, and we want to share this transformation with our partners and with our customers, opening the environment and our professional kitchen to co-develop and co-create new recipes. And we are also transforming and changing the business model. So through CLEOS, we are able to support business models that were impossible to sustain before, simply because they required too many resources and too many work to be managed. Today with CLEOS, since we have a centralized platform that is selling data, processing services, and information products, we are able to put in place new data monetization strategies, or also API monetization strategies with the maximum flexibility. And we're able to test the market with this new offering, receive feedback, and adapt. And I'm coming to the point that is actually having CLEOS as part of the ecosystem of platforms that we see growing in our business, so in the geospatial domain, but more and more also out of space, as Francesco was saying. So for us, CLEOS is the investment to be part of this platform economy and be able to grow our business together with our partners, because we are looking for federation and interoperability also with other platforms like One Atlas from Airbus, like Digital Globe with GBDX, and many others. We are really open to that, and we are fostering that also with the adoption as much as possible of standards. And here again, Mariano will provide more details. Good. Let's go live. Okay, good. So you can type www.cleos.earth, you can register, and after registration, you are logged into the platform. This is actually a brand new concept since it brings the typical functions of a marketplace. You can see the cart, you can see MySpace into the world of geospatial information. The offering is clear, it's satellite imagery, information products, and processing services. And you can then explore the different categories and have a brief overlook of what's available there. So we started with a limited number of processing services focusing on SAR, since we are well recognized globally as a SAR data operator. But we also include the access to information products. We started filling this section with freely available Copernicus datasets that are accessible through a single and unified interface, and we are welcoming the onboarding of additional sources here. And clearly satellite imagery. It's radar and optical. And for us, it's important actually to have been able to bring the core of our business and our core asset, that is Cosmos SkyMed, a few clicks away from our customers. In this sense, with a single click, you can enter into the platform and you can access to the geo configurator to make integrated searches between different SAR data sources. In this case, it's Cosmos SkyMed and Sentinel-1. Here, it's no surprise. There is a geographic search that we are all used about. So it's based on area of interest and the time of interest. But the big effort has been actually to go for unification of interfaces and of catalogs, federating different catalogs and allowing our users and customers to be able to search for multiple data sets. And this was also our internal requirement. And believe me, when we have been designing CLEOS, we have been thinking first of our internal needs, imagining that what was good for us could have been good also for our customers. Like for instance, here we have an experience of selecting a strip from Cosmos SkyMed. You get immediate information of which are the single frames that you will receive. You can also get the preview of the data, again, integrated. And this is just the beginning, because CLEOS will continuously evolving, adding functionalities and tools. And here you have the simple experience of adding items to the cart. You are prompted to insert some technical details about, for instance, processing level that you want to receive Cosmos SkyMed data. And in a few seconds, orders are flowing directly into the cart. One important thing that we are releasing with CLEOS is also the free access to Mapitali dataset for Italian users and customers. Mapitali is the systematic acquisition mission designed by the Italian Space Agency and the Italian Civil Protection, implemented by e-GEOS, to have systematic interferometric acquisitions over Italy since 2009. And now, all this dataset from 2009 to 2019 is available, ready for download, already processed in level 1A format. You can have direct access also to high-resolution browse images. And the incredible thing is that these data are available for download, for immediate download. So we don't need to, let's say, process them, taking more time, but you can instantly get access to them. And also, we have been implementing a very nice feature to have a look to interferometric stacks. So here we are grouping results according to stacks that are identified by the incidence angle, in this case for Cosmos SkyMed. You can easily switch from one view to the other. Once you have the stack, you can also easily select which are the data belonging to that stack that you want to get into the cart and that you want to buy. So this is actually a big step forward for all those users and customers that are dealing with interferometric processing and that want to get easy access to interferometric data. And we will also have a closer look when launching a processing service. We are now in the cart. This is a very familiar style from all different marketplaces that we are used to. We can review the items that we have inserted. Here we see that Cosmos Climate Map Italy is at €0 since I'm Italian, and I can get free access to this data, as well as Sentinel-1. After that, I have reviewed what's in the cart. I can inspect the full detailed metadata, and I can also configure some product options. So I can ask CLEOS to store data in the cloud for me for more than 15 days, that is the free standard options, in case I would need eventually to process and access again this data into the cloud. And I can send a comment to our customer service. It's very important to say that behind CLEOS, there is a customer service, because we have been pushing on automation where it makes sense and where it's possible to do that. But we have also our professional and experienced customer service to take care of all those more complex situations that require assistance. And now I am ready to proceed to payment. So in this case, it's enable only wire transfer. Soon it will be possible also to pay by credit card, also supporting microtransactions. And now I have placed my order in the system. Now there is an alert to our customer service. Some steps are have been taken automatically. And actually now this is an active order that will deliver data and products. Even more interesting is the effort that we have been done in making available scalable processing services. So this is just not an information that you can. So there is an interesting product that is called multitemporal radar coherence that provides information on changes between two interferometric SAR images. You get detailed information about the product, but the incredible thing is that you can also configure and launch this processing. Here you are guided. So since MTC, multitemporal coherence, requires interferometric data, we don't want our customers to get lost in selecting those data that are fitting all the conditions for being interferometric. And so we already set some details and some parameters so that our customers are getting directly data that can be processed together to generate multitemporal coherence products. So these are all Sentinel-1 stacks already organized in a fashion that is what you see is what you get. You can again enter into the stack. You can select only the images that you want to process. So in this case, I am selecting data from 2 different passes. Now I'm adding the third. And I see also which is the common area of intersection between the data that will be the area that I will receive as a customer. I'm now able to set all the necessary parameters to launch the multitemporal coherence processing. And I am sure that this processing will be injected into our processing platform, and that multiple worker nodes will start grabbing the data from multiple sources. So in this case, we are taking data from Onda and Mundi Dias, and they will be able then to be processed with horizontal and vertical scalability, as my colleague Mariano will provide more details in a few moments. So what's important is that I have always the situation under control. I can remove some data, I can remove the processing, I can change things before I proceed to checkout, and I proceed to sending the processing order to the platform. This is something that is very important for our customers, but that is very important also for our colleagues. We have been listening a lot to them. We have been listening to their troubles, their pain points, and we have been designing CLEOS in a way that it's able actually to address their pain points efficiently. And so actually the success of CLEOS it will be based on also our internal adoption. And be sure that new features that you will see in CLEOS in the coming weeks and months will be based on also on our first feedback. Okay, I would like to stop here with the live demonstration, since mainly you can do it yourself, simply inserting CLEOS.earth in your search bar in your browser. And I would like now to leave the floor to Mariano for the more technical insights. Just one final remark. Stay tuned, because in the coming few weeks, we will be releasing CLEOS API. It's a major step because we now have a great user interface that still requires some clicks to configure products, to send orders, and to get information about where the order stays. Very soon, everything that I've been showing today will be available through a secure API. And this, I'm sure, will be, let's say, quite an exciting news for all our Cosmos Climate customers, but also for all those users that are interested in connecting to CLEOS to get data and to get access to scalable processing services.
Okay, so thanks Domenico first, and thanks to everybody for attending this session. So guys, if you could enable me to share the content. Okay, thank you very much. So perfect. My name is Mariano Alfonso Biscardi. I'm CLEOS Technical Manager. In this session, we will have a short technical overview over CLEOS technologies and concepts. So as Domenico was presenting before, CLEOS at an high-level architecture is composed by three main tiers: the marketplace with the web UI and then the API coming, the processing platform responsible for the scalable execution of data processing pipelines, and then the data lake where all the data are ingested by data collectors collecting from different data sources. But what are the CLEOS enabling technologies? CLEOS is developed upon dozens of different technologies, from open source to commercial ones. From an high-level perspective, this could be grouped into an access layer based on CrowdCraze, Leaflet, AngularJS, a data access layer with an API manager to perform API counting, billing based on API calls, then a processing platform that has an API, a service registry, a processor that is called a MAJ to perform SAR processing that is internally developed by e-GEOS, and all the monitoring, UI administration, the catalog with data catalog based on Elasticsearch, and so on. We have also the infrastructure layer with all the infrastructure supported that are mainly AWS, Google Cloud Platform, and all the available DSS with the Mundi, on, and so on. And finally, the CI/CD layer with Puppet, Foreman, Jenkins, and so on. But aside from technologies, CLEOS is mainly developed above four main pillars that are unification, standardization, data locality, and scalability. Unification. In the market with hundreds of similar solutions, how can we facilitate users onboarding? Then, standardization. Regarding the data catalog, for example, how to navigate, search, access the data catalog in a standard way. And then data locality, how can we move workloads to the data and not the other way around to save bandwidth and to increase efficiency. Last, scalability. Software platform infrastructure can have huge costs. We all know that. If we want to support thousands of users, how the infrastructure can be reactive and contain costs at the same time. So we will talk about these pillars in the next few slides. First of all, unification. How do we achieve that? How do we do this? This was performed to the adoption of OpenEO. OpenEO is an H2020 project funded by the European Commission, and the task of OpenEO project is to design, develop, and evaluate an API for cloud-based observation data processing. The current situation is the one showed on the left part of the slide, where currently each backend have its own API. So the different clients has to call the different backends, integrating and developing new functionalities to adapt themselves to each backend. Then the paradigm is switched to the one on the right side of the slide, that is one of OpenEO, that is increasing the possibility to integrate backends with their capabilities and to compare backends. So in this case, OpenEO is abstracting the backends and giving one single interface to each of them. For example, in CLEOS, we have adopted OpenEO and we are creating new batch jobs, start processing a batch job and getting the full metadata for a batch job, just following the interface specified by OpenEO. The other pillar on which we developed CLEOS is standardization. In particular, we have standardized all the data catalog and the metadata catalog. We have done this with STAC. STAC stands for Spatio-Temporal Asset Catalog, and is a specification that provides a common language to decide a huge range of geospatial information so that it can be easily indexed and discovered. A spatio-temporal asset is any file that represents information about the Earth. In particular, STAC specification provides as a lowest common denominator the JSON format to wrap around any relevant data about the Earth. The core GeoJSON object and the related structures are designed for extension. In particular, we can see here the definition in STAC of an asset object that is an object that contains a link to data associated with an item. In this case, we have for each asset that could be a satellite acquisition, for example, a Sentinel-2, a Sentinel-1, and so on, that is described by is linked to in the href, in particular, the title, the description, and the type. Then we can see here an example of our multi-mission catalog. In this way, by using STAC, by standardizing the way that we ingest datasets, we have composed a new multi-mission catalog with 50 million records. And for example, here we have a Sentinel-2 that is an optical acquisition, and now we can see in the part of the assets that are available a lot of providers to access to the same data. For example, AWS, Onda, Scopub, Shiap, each one with this reference. And then combining the multi-mission and the multi-cloud support, CLEOS could move workloads to the data, and the processing chains can understand where to perform some processing job, giving the availability of the data itself. So this leads me to the third pillar, that is data locality. And data locality means moving computation rather than moving data to save bandwidth. Of course, we have huge tons of terabytes of satellite imagery in different places offered by different providers, and the fact to move data towards to move workloads towards data minimizes network congestion and increase the overall throughput of the system. This one that you see in this picture is a screenshot of our infrastructural occupation over CLEOS. You can see that we have a tenant on AWS, a tenant on Mundi, a tenant on EarthLab Cloud. You will see soon what is EarthLab. And of course, we support also Google Compute Engine and of course, on-premises infrastructure. So I was mentioning EarthLab, and first thing, what is MaxACS? CLEOS processing platform is based upon a solution called MaxACS, that is a platform as a service developed by EarthLab Luxembourg. In MaxICS, the user has a graphical user interface from which design it workflows, and that leads me to the latest pillar, that is scalability. Each processing chain in MaxICS and so in CLEOS developer portal is developed composing nodes and flow. When a node is linked to another, a RabbitMQ queue is deployed to perform the communication between the nodes. And the velocity, the ingress velocity of the messages to the queue and the egress velocity of the messages from the queue are calculated and monitored to calculate data pressure. The worker nodes, for example, here you see that the loaders has three numbers associated, 50, 50, and 200. 50, the first number, is number of currently deployed node. 50, the second number, is the number of minimum deployed node, and 200, the maximum desired node. So in this case, monitoring the pressure, the infrastructure will scale accordingly in terms of microservices. Then the infrastructure below is scaled via an autopilot feature that deploys new instances to fulfill the new workers' hardware requirements. Another concept behind CLEOS is the perspective. So we thought that a certain user could perform the same operation with different levels of complexity and perspective. For example, here we can see a user that is performing data download request to CLEOS web user interface. But through CLEOS, it is possible also to develop a new data download pipeline. So let's see that, for example, here, the software architect perspective is made by MaxICS. In this case, for example, the software architect that wants to develop a download pipeline over CLEOS goes to our developer portal and then select the API component and its characteristic. Then it could imagine to have a downloader microservice that perform the actual data download from all the providers supported by CLEOS, and then it can imagine to have a last microservice that is the delivery node that is performing data delivery to the user, the end user, and notifying the data availability. The composition of the workflow inside CLEOS developer portal is made just like this, and that's how we developed our internal pipeline. The latest perspective, the last perspective that I want to show you is the developer perspective. So in this case, we have the developer that wants to develop the downloader node that you have seen in the UI. Here in CLEOS, we have developed some libraries unifying the access to the data. In particular, here we have the set imagery downloader library that supports AWS, Onda, CropUp, SciHub, and other data sources. And in this way, a certain developer could access all those data, and the complexity and the APIs of each provider are masked behind a simple interface that is the one provided from our library. Then, last but not least, I haven't mentioned it yet, we have fully integrated inside CLEOS artificial intelligence capabilities, a full suite to perform machine learning and deep learning inside CLEOS, and my colleague Simone Tilia will show you which are the capabilities that we have integrated that will be soon available in the market for external users. Thank you for your attention.
Thank you, Mariano. Okay, now I can share my screen. So, my name is Simone Tilia. I work as a data scientist in e-GEOS, and thanks to all for the participation. And now I want to show, so as said by Mariano, the AI factory. And so we called factory because in our AI factory we can do all the steps necessary to build the AI models. And so I bring them to production and use them to solve business problem. Actually, how can we solve these problems? We have to build models, to load data, and we have a lot of passage to do. In our platform, we can do all these steps. So we can load and label our data. We can load reuse AI models. We can train or fine-tune our AI models on our data that we loaded and that we labeled. And finally, we can also put models in production easily. And that's important to approach and solve the business problems, the real world problems. Here we have the AI models loaded in our platform. Cannot see my. Okay, here we have our models loaded. For example, we have ResNet, etc. And so the first step, as I said, is to use images. So, for example, for a classification or for our object detection, here we have an example of data set provided by Airbus that we have loaded. This is an object detection task, and as you can see here, we can use our platform, so our AI factory, to label the data, and we can zoom in the image, we can delete some labels, we can add, of course, labels, and so we can build our data set to solve the problem. In this example is a car detection problem. And yeah, we can see that, of course, the data set is already labeled. And then we have to choose our AI models. As I said before, we have different AI models already available. And of course, you can also load our model. And for example, there are a lot of interesting models as ResNet 50 pre-trained, also pre-trained, because it's important and always to start from pre-trained models. Here is the factory. So I built this factory for today, and the factory is the mode, is the tool to train models on our dataset. So in the example here, we select RetinaNet. We have some parameters for augmentation and other parameters to train our model. So here on top, we can select our dataset. As I said before, we use DOTA, for example. And then we have to select the loss and the number of epochs and the dataset radius, because as you know, we can have the train. We must have train, test, and validation set. And then we have simply to put a name, and then we can start the training. Finally, after the training is done, we can use it in production. We can build a new pipeline. We can insert the new nodes, and of course, we can put our trained model in production using a simple node that is called deep learning, and so we can deliver results of our deep learning models very easily. That's all.
So thanks to everybody. Francesco, I guess you have the
I'm sorry.
have the last word. Yes. Okay.
I was moved. Okay, I say again. So thank you, Simone and Mariano, to stress this platform together with the Luxembourg team. And I would like to first of all close this event and thank you, Emmanuel, Greg, Gunther, and Francesco to join us and to promote this activity in the UN and in the other ISA and WGS and WGS IAM. Thank you to all the attendees, and we are waiting on www.cleos.earth.